Hello and welcome to my new Philips P3230 desktop PC. A computer that was kindly offered to me by a subscriber who saw another computer in one of my videos that he had when he was young, so he offered to trade it with me. A gorgeous 286 desktop PC from Philips. But it wasn't quite as beautiful when I got it because it actually looked like this. So there was a lot of gunk on the case. I think it was probably like mold or something because it was very difficult to get off, both on the bottom, on the top, on the sides. Everything was pretty filthy. So the first thing we needed to do was take a look inside to see if this PC would actually be salvageable, because I have no idea how it got this dirty. So in order to get the case off, we need to remove the little feet beneath the desktop case, and then the case just slides open. And as I was opening up the PC, I noticed that there was like water damage in this particular area of the PC where the motherboard resides. This didn't give me a lot of hope, but the inside of the PC was actually pretty clean, so think that this was worth some additional investigation. Now, as I already said, the case was very filthy. Cleaning it turned out to be quite the task. I need to use some baking soda to get the dirt off. So I ended up having to scrub the whole thing off pretty hard, but the result was pretty much okay. And I also used this kind of bathroom cleaning stuff. And all in all, the case turned out pretty well. I was able to clean off everything. So at least we've got the cleaning part out of the way, and now we can focus on the actual PC. And as I already mentioned, looking at the inside of the machine, it's just as if it left the factory yesterday. It's really clean. On the back side, I did notice a lot of corrosion where the water damage appeared to be. The connectors were pretty filthy. The front was not all that bad. It also needs a little bit of a cleaning, so I'll be removing the front cover as well. So the front cover can be removed by removing a couple of screws here, and then we can take it off completely. So let me go over the components real quick here. We've got the hard drive here, which is a model that I like very much. It's a Seagate ST157A. It's one of these old IDE hard drives. I really like the color and the model of it. The only expansion card is the video card here, which is a chips based video card branded by Philips, and it has both a VGA and what appears to be an EGA or a CGA connector. The computer also comes with two disk drives, one 3.5-inch 1.44 megabyte floppy disk drive, and one 5.25-inch and what I think is a 360 kilobyte 5.25-inch floppy drive. Now, given what I saw in terms of potential water damage, I did want to peek inside the power supply to see the condition of it, and again, like much of the inside of the PC, it was pretty clean. I removed the power supply from the case because I wanted to test it in isolation. I also needed to remove this external power connector that comes out of the case, which feeds into this power button here. And then we can remove the power supply and also get a better view of the main board. So this is a Philips branded main board, made specifically for this PC. As you see in a lot of these proprietary desktop cases, it has an integrated IDE controller for the hard drive, floppy drive controller. It has 4 SIM sockets, and it has one expansion card, which is the video card. At the heart of the system lies this Intel 286 12 MHz CPU. But moving to the power supply, I did want to test the power supply in isolation, so I just wanted to see if there were no shorts and if all of the voltages that come out of the power supply are okay. So as I switched on the power supply, I first focused on the 5 and the 12 volts coming out of the Molex connector. That seemed to be fine. And then I also checked all of the other voltages that the power supply needs to provide, and also all of these turned out to be okay. Now the main board is attached using plastic clips, and it's held together on the case using the back connectors. So we'll need to remove these little screws here before we can slide the motherboard out of the case. And here we can see this kind of water stain that has been left here on the case, but the motherboard itself looks very nice. It looks almost brand new. The G2 chips that you see here make up the chipset of this main board, which was later purchased by Headland Technologies, a very popular chipset maker for a lot of 286 based systems. Here we have the onboard floppy drive and hard drive controller, a piezo speaker, and 4 SIM modules that should make up 1 megabytes of RAM. But now, moment of truth, let's hook up the video card, attach the power supply, and see if it turns on. And Lord and behold, it does. We are getting some errors on the screen, together with the beautiful piezo speaker sound. And what we see here is that there are RAM errors, CMOS battery checksum errors, and at this point the only thing it could do was boot from a floppy disk. I did replace the SIM modules to see if the memory error was related to the chips itself, but nothing changed. I still got the same memory error. Now, given that this computer does not have a built-in BIOS setup program to set up the various system options, instead it relies on external apps that can be run off of a floppy disk. Now, the goal of these external apps is to set the various system options, encode that information so that it can be saved in the CMOS chip of the computer. So I tried a bunch of these generic AT-based setup programs that allow you to configure the system options, but none of them seemed to work. At the end, I did find the original setup program for this computer. It's in French for some reason, which is a bit odd given that Philips is a Dutch company. But it allows you to configure 2 disk drives, the A and the B drive. It has a set of predefined hard drives that you can specify, including the Seagate ST157A that was on it. You can configure the default turbo mode, serial parallel ports, and I was able to save these settings and the memory error went away, but I still got the CMOS battery checksum error, so there was a problem with the CMOS battery. And of course, what we see here is the infamous Dallas RTC clock, which is included on this main board, which always gives issues on these old computers. So what we're going to be doing here is we're going to be removing this chip. So I'm going to be adding a little bit of solder to these pins here so that I can then use my desoldering pump to get rid of the excess solder and free up the chip, the pins of the chip, so that it can be removed fairly easily. I did the same for the bottom rows, and then I just used a screwdriver to kind of pry the chip out of the pins, because there's also like a small amount of solder that remains there. It's very difficult to get everything off, but by gently prying away the chip, you can get it off without damaging the chip or the main board. We are going to be inserting a socket onto it, just to make the life of the next poor sob that will take over this PC a little bit easier. And here we have the Dallas RTC chip that has the dead battery inside, preventing the PC to boot properly. Now, you can still buy these Dallas RTC chips new. They have a life expectancy of about 5 to 10 years, and they can act as a drop-in replacement of these older Dallas chips. Notice that the chip number is a little bit different, but they are pin compatible. So like I said, this chip does contain a battery inside of it, and there is a hidden positive and negative terminal here that connects the battery onto the internal chip here. Now there is a way to repair or hack an existing Dallas RTC chip using an external coin cell. So using a coin cell holder like this, we can place it on top of this Dallas RTC chip and then disconnect the internal battery and rewire it to this coin cell holder. So this is a fairly popular hack that a lot of people use. It does involve some tooling, so you'll need to have some kind of Dremel tool to expose the positive and the negative terminal, which is kind of bent over. As you can see here, it's not exposed on the bottom of the Dallas RTC chip. So you need to carefully remove the housing of the chip to expose the two pins. And then what you need to do is you need to find the actual terminals of the coin cell, which is included here, which is located at the top of the chip. So for example, here I'm exposing the terminal of the battery, and if I do a continuity check, you can see or hear that these two are connected. What you need to do now is you need to cut the internal battery in this chip. You need to cut the terminal away from the pin which is bent over on the bottom here, so that the battery becomes disconnected, and you do a continuity check to verify that. And then you can hook up some wires to the two bottom pins to hook up your external coin cell. Now I'm going to be doing this in a quick and dirty way because this is not going to be a permanent solution for this computer. I just want to show that it is possible to hack an existing Dallas RTC chip and make it work again. So you just hook up the external coin cell holder here using the correct positive and negative terminal, and then you can insert your coin cell, insert the Dallas RTC chip into your PC, and see if you can correctly store the CMOS settings of the PC. So here we again launch our setup program. We configure the system options that we want to configure, such as the disk drive and the hard drive. We can also set up the turbo modes and the serial and parallel ports. And notice that after a reboot, not only the memory error disappears, but it also finds the internal hard drive. It doesn't report the CMOS error anymore, but unfortunately it doesn't want to boot from the hard drive. So I attempted to boot it from a floppy drive, and I could access the C drive now, but as soon as I launched the directory command was hanging and the hard drive was producing a, how should I put it, a non-standard sound, and I got sector not found errors on the hard drive. So at this point I thought that the hard drive was toast, despite the fact that it was able to see the content and see the partitions and everything. From time to time I also got the disk controller error, accompanied with a nice speaker sound. Formatting the drive also didn't solve anything, as about 1.5 minutes into the formatting, I again got the sector not found errors. Unfortunately, I was very limited in the number of hard drives that this system supports. I didn't have any of them. So I did want to check the condition of the original Seagate ST157A drive, so I removed it from this bracket here and decided to look at the platters to see if there was anything obvious wrong with this hard drive. Now I have yet to find a working Seagate ST157A. I do have other computers with these hard drives installed on them, and all of them turned out to be failures. So let's see how this one looks as I open it up. Now, I don't recommend opening up hard drives just for the fun of it. I'm pretty sure that this one is dead and cannot be fixed anymore, so I just wanted to look at the condition of the platters here. Upon close inspection, I already noticed on the top platter that there was surface damage on the top platter in this particular area here. I don't know exactly what caused this. Normally a head crash causes kind of these circular markings on the platter that clearly indicate where the head crash occurred. This wasn't the case here, but I needed to look for a replacement. Now the setup utility only supports a limited number of different hard drive types. Now the closest one I had in stock here was this Commodore hard drive. This is a 250 megabyte hard drive. Now the setup program only supports a 100 megabyte Commodore hard drive. So I decided to give this one a try. So I inserted the hard drive onto the bracket, installed it into the PC, and I was able to format it without any issues, albeit only using the 100 megabyte as set up in the CMOS utility. So as I said in the beginning of the video, I'm not particularly fond of these Dallas RTC battery hacks. So I decided to use a brand new Dallas RTC chip on this computer here, putting it into the socket that we added to the main board earlier. Now, one final issue I had was with the 5 1/4 inch floppy drive, making this horrible noise on startup. So it turned out it was this head shaft that was kind of stuck. Now I was able to loosen it up, so the problem went away by itself. So all in all, I'm really happy with how this restoration project turned out. The filthy case cleaned up quite nicely. It does have some light damage, but it's hardly noticeable. So it turned out really nicely. I really like the look and feel of this PC. I installed MS-DOS 5.0 on it, and it was able to boot it without any errors. So I really hope you've enjoyed this little video. I might feature this PC again in a future video as I play around with it a little bit. So please consider subscribing to support the channel, and I hope to see you guys soon. Bye bye.